Okay, this is a continuation from yesterday where we learned to graph reciprocal functions. This is the one we didn't get to. And what this involves is I'm going to give you a graph. We have to work backwards and find the equation. Okay. So let's look at this for a second. What we're going to do is we're going to graph. I'm going to actually graph this on here. You're going to graph this main piece here. That works. Okay. So what we have here is we have a vertical line. It's a dotted line. So it is a what? An asymptote. Okay, so what is this asymptote? What does x equal in this case? 2. Okay, so we know then in this one that in our reciprocal, what could the bottom never be?
2.
Right, it can't equal, because if we plugged in a 2, it would make the bottom equal to 0, which would be an NPV. Okay, that's useful to know. Okay, now what we're going to do is we're going to graph the actual reciprocal on here. I didn't do it on yours because it wouldn't show up very nicely on the graph. Okay, so the point we want is, where is it here? Right there. 3 1/3. Okay, this is the point. I'll put it on here and I'll draw it through, and then I'll label it just so you know. So there's the reciprocal. This point right here, I'll label it as 3, 1/3. Okay? I'm giving you this. I just didn't draw it on the original graph. When you get a question like this, you're going to get the graph like that. That's what it's going to look like. Okay, so let's think about this for a second. The reciprocal, the asymptote is 2. Okay? So on the original graph, what does that tell us? If the asymptote is 2, what does that tell us on the original graph? The x-intercept. Is that correct? Yeah. Because the x-intercept on the original then becomes the asymptote on the reciprocal, right? So if we're going backwards, if we know the asymptote, then guess what we know? We know the x-intercept. So on the original, the original, the x-intercept is, what is it? 2, 0. Is that correct? Or is that a point? Okay. Now, here's the thing. I don't know if you've noticed this before. Remember yesterday when we did the y-intercepts, right? So for instance, if the y-intercept was 0, -2, which part flipped when you did the reciprocal? Do you remember yesterday? I'll just draw it on the sideboard here. It doesn't matter what the line is. What did this one become? What did this one do? Where did it go? Didn't it go 0, 2? Yeah. Remember that? Okay. So what part are we flipping? The x or the y? The y. Okay, now let's try this one. Do we know that point right there? Do we know the point on the graph? Okay. So the point on the graph right there, the current one, so on the reciprocal, the point is 3, 1/3. So what is it? 3 and 3. So the point on the original is going to be 3, 3. Right? You just look at that. You know that the only one that flips is the y. Right? Because when we did that, it was y equals, we flipped it, right? So the y is the flip of the x. Right? Think about what a reciprocal equation looks like. Right? The original is going to be y equals mx plus b, right? And when we flip it, the reciprocal is y equals 1 over mx plus b. So we just took that one and flipped it. Okay. Now, let's see if you remember this stuff. This is from back, grade 9 and grade 10. If you have a set of points, and you have a set of points. Can you figure out what the equation is? Do you remember this? An idea? If I gave you two sets of points, how do you find out what the equation is? No? So here, let me write this up before we get going. Okay, so what we're trying to find here, guys, is this is what we're trying to do. We're trying to find the equation. Find the equation for, what was it again? What were the numbers? 2, 0, and 3, 3. Okay, if we want slope-intercept form, right, we want it as y equals mx plus. We need to know two things, don't we? We need to know the slope, and we need to know the y-intercept. Don't we need to know that? That's true. Do we need to know that? Okay. It's an and. That's the shorthand version of an and. Would you rather me do that? Not going to happen. Okay. Well, how would you draw? We're not talking about that. How would you draw the 2, 0, and 3, 3? What's the slope? Could you use the standard formula m equals y2 minus y1 over x2 minus x1? Do you remember that?
Yeah.
You learned it in grade 9.
I remember that.
Now, could you be smart about this and actually think about the question instead? What is 2, 0? Is that 2, 0 right there? Where's 3, 3? Up 3 over 1. What's the slope? 3 over 1. Do you actually even have to do the math for this one? Okay, guys, let's look at that again. The y-intercept is right here. Is that correct? 2, 0. The other point is 3, 3. Now, the nice thing about this, it's a line, right? So no matter whatever point you pick on the line, the slope is the same. So basically, you go from 2, 0, you go up 3 over 1, up 3 over 1, up 3 over 1. So what's the slope? 3 over 1. Or we could just say 3, right? So do we actually know the slope? So we're saying that the slope in this case is actually 3. Now, what if you couldn't see that? What if that didn't occur to you? Could you use the y2 minus y1 over x2 minus x1? Do you want me to do that quickly on the board?
Yeah.
Let's do this quickly just so you get this. M equals y2 minus, oops, that's not a minus. y2 minus y1 over x2 minus x1. Now, you got to take your numbers up there, you got to label them with the x1s and the y1s. The only thing you have to remember is, if you label this 2 as an x1, what do you have to label that 0 as? A y1. The numbers, the ones have to go together. It would work if you label these first of them as 2s and the second of them as 1s. Do you remember this?
Yeah.
Okay. So, yes. x1, y1, x2, y2. Let's plug in what we know. What's y2? 3. What's y1? 0. What's x2? 3. What's x1? Which is 3 over 1, which is 3. Didn't we know that, though? Yeah. Right. You can do it mathematically wise, but sometimes it's better just to use the old brain. Use the old noggin. Yeah.
So what if this was wrong? What if 3 and 3 were x?
Well, let's do it backwards then. What if these were 1s and these were 2s? So then it would be 0 minus 3 and 2 minus 3. So you have negative 3 over negative 1. What's a negative over a negative? You still end up with the same answer. It doesn't make any difference whether they're reversed. The only thing you have to remember is the ones have to be together. You can't do like x1 and y2. It doesn't work that way. Right? Because it's the change in y over the change in x. Rise over run. Right? Change in y over change in x. Okay, now, you know the slope. What's the other piece that we're missing? The y-intercept. So do we know an x and y value already? We have a 2 and a 0, that's one set, or could we use the 3 and the 3? Does it make any difference which one you use? No, it makes no difference whatsoever. Okay, so let's go back to the original equation. So y equals mx plus b. Which set do you want to use, the 2 and the 0 or the 3 and the 3? 3 and 3? Okay, that's easy. So 3 equals, what was the slope? 3, what's x? 3 plus b. Right? What's 3 times 3? 9. Move the 9 to the other side, what's b? Negative 6. Thank you.
What? Oh, yeah, sorry.
Basic algebra. Okay, so what's the original equation then? Y equals x minus. That's the original equation. What would the reciprocal be? Y equals 1 over 3x minus 6. Is that right? Didn't we say x couldn't be 2? What's 2 times 3? 6 minus 6 is 0. Undefined. Okay, let's draw on the original then. Wait, I'll wait till you write that down. Do you remember some of this stuff from previous, right? It's the same stuff we learned in 9 and 10, right? Actually creating an equation. This is a little bit different than what we did yesterday because we're going backwards from the reciprocal, right? You done? This is why, because you're eating when I'm doing this, that you're a little bit behind now. And now you're holding up the whole class. Okay, so it's, what was it again? 3x minus 6. So where's the negative 6? 1, 2, 3, 4, 5, 6, right there. And what does the slope mean? We go up 3 over 1. Up 3 over 1. So here we go. Up 3 over 1. Up 3 over 1. Hey, did we know that? Yeah, we did. Up 3 over 1. Okay. So what do? Can I draw my line now? You guys understand slope, right? Rise over run. Up 3 over 1, up 3 over 1. Right? It's just like a set of stairs, right? Let's draw the line. What don't you understand? I can hear. Oh, where is it there? Right there? Adjust this a bit. This board never works properly. It's kind of weird sometimes. Okay. So this is y equals 3x minus 6, and this other curved line in here is y equals 1 over 3x minus 6. The original and the reciprocal. The original is the linear, the reciprocal is the nice little curve, right?
So the line is the original, then the curve.
The line is the original, and the curve is the other one. I guess I could have done them in different colors for you, but you should be able to figure that out. Does that make sense? It's a working backwards question. I think there's a couple of these in the assignment. Original, reciprocal.
I know, so the one that curves along the red line.
Is the reciprocal. Here, do you want me to put an arrow to it?
Just out of curiosity, if there was like the other side to the question.
Not in this case. Because we didn't draw it in this case. And it would be in reality, yes. But in this case, what I would give you is just the one quadrant. And you really don't need the other quadrant, right? Because where would it be? It would be down here, right? You know that already, right? What's going to happen eventually in grade 12, actually, no, I don't think we covered it in 11, is you're going to start seeing these where they're both on this side. They're both on the top. And that's kind of have to do with, didn't we have graphs where everything flipped from 3 and 4 into 1 and 2? What were those called? Those graphs that flipped from... Oh, so can you do, now there's a question for you. Can you do absolute value of reciprocal? Yes, you can. And really, it's, think about what you've done. You just follow the steps. You draw the original, move everything into the other quadrants, right? You'll get to that. It's kind of cool. Anyway, so you have all the class to work on the second part. Put it power, get at it. Your test is when? Tuesday.